Um, yeah, let me click this. So I want to start actually. I know some of you are in Paris. I want to share with you a 19th century vision for the year 2000 that was developed by a number of French artists in between 1899 and 1910. And they got some things right. So they see, for instance, the mechanization in farming coming, in agriculture coming, as you see in this image. They even kind of at the time foresaw something similar to Roomba. There's a little robot, cleaning our homes. But they also got a bunch of things terribly wrong. So, for instance, they thought we would actually move in the ocean with what they call the whale bus, or that the police would actually move in the skies of Paris like this. And even if you got, a drone fantasies, this is still very far from reality. And the reason I wanted to share this is about, what from an epistemological point of view, what is interesting is to think about the future. This is Karl Popper. And he says in the myth of the framework, he says the future is open, it is not predetermined, and thus cannot be predicted except by accident. As we saw, they got something right, but kind of it was a bit random. And so the possibilities that lie in the future are infinite. And the way to really to explore the future, we believe, is design, is using design in order to explore different ways our cities could evolve. But when I say design, I mean design, something you could call design at large, involving many different disciplines, involving complex science, mathematics, AI, and so on, in order, again, to transform our cities. Well, let me tell you also why we're passionate about cities. If you need to remember just 4 numbers about city, remember 2, 50, 75, and 80. Cities are only 2% of the surface of the planet, but they're 50 or 55% of the population, 75% of energy consumption, 80% of CO2 emissions. So if you can do something to make our cities a bit more sustainable, that can be a big deal globally. And the way we can do it today, a great opportunity lies in what you're seeing here, the convergence of digital and physical. One way to say it is that the internet is becoming Internet of Things, is entering physical space, the space of the city, as it's changing. The way we can actually understand it through data, analyze it, again, by applying analytics to the data, and ultimately design and live in it. As I mentioned before, we do this with different operations with Senseable City Lab, our research lab at MIT, with our design office in New York, in Italy, in London, and also with some of the startups. They came out of both in recent years. But without wasting too much time on this, on introductions, I want to share with you a few projects. I just put together kind of a small, a few of them just to start the conversation. I can show you more things than later in the Q&A if needed. This is actually a very old project. We did at the Venice Biennale. We had a pavilion, the Venice Biennale, back in 2006. But the reason I'm showing you this is that this was actually the first project ever where we looked at large amounts of real-time data collected from a city, in particular from the cell phone network in a city. In this case, this was shown at the Venice Biennale, so we picked the Italian capital, Rome. But for the first time, we got this kind of big data being collected in real time in Rome, being sent, as you see here, to a number of servers we set up at MIT. It was then analyzed, visualized in real time at MIT, and sent back to Italy and shown at the Venice Biennale. And that was actually the first time. Well, maybe the first time was the year before we did a similar test, but this was the first public experiment where we tried to look at, again, all this kind of big data, especially from cell phone networks, to describe a city. And if you look at some of the papers from the time, some of them are still used today, as a basis for understanding a city with all this kind of mobility, mobility and communication data. And for instance, something we discovered with data that's very similar. So that previous paper and the project is from 15 years ago. But this is a paper from actually just a few months ago. We're analyzing all this kind of big data about mobility in the city, especially from cell phone. We found this, which we call visitation law of human mobility. I will not get too much in detail. That's a Nature article where it was published a few months ago. But basically looking at a very interesting dependency between how far we move and the frequency of movement. Something, in the past, people looked a lot about mobility between cities, mobility between population 1, population 2, two cities of different population. But because we didn't have data such as cell phone data, we could only look at aggregate flows. It turns out when you look at cell phone data, when you use cell phone data and you look at the spectral distribution of frequencies, it follows a beautiful law that basically it's not 1 over r squared, but it's 1 over rf squared. Again, I don't want to bother you too much with this, but that was just to say that with data from networks, we can understand very interesting things about cities. And we can really look at a city like this. What you see here is Lisbon mapped using billions of data points collected, again, big data from the mobility network in Lisbon. It's like a living organism. We couldn't see a city like this 20 years ago. Incidentally, this is a visualization by Pedro Cruz, who was in our lab at MIT as a researcher. Now he's a professor at Northeastern, and he did it. And this kind of seeing a city like a living organism was part of a lot of the investigations we were doing at the time a few years ago. And then again, you take the data, you analyze it, you can discover interesting things. Again, this is a similar data to the one I showed you before. That's actually taxi data in New York. Every dot is a taxi pickup or drop off. You see it with different colors. This is JFK Airport. If you zoom out, you see JFK there. You see Manhattan and all of the boroughs. And this was a few years ago. We started asking ourselves a very simple question. If you look at 2 points in Manhattan, you got hundreds of thousands of trips connecting them in the course of the year. And so our question was, how many of those trips could be combined? People sharing the same vehicles together because they're going more or less in the same direction. When we started this, Uber had not launched Uber Pool yet. So we started looking at this investigation. When you want to, sometimes we say, when you need to analyze large amount of data, you need to develop new mathematical tools. So in this case, we developed something that we call shareability networks, using network science to solve the problem I told you before. You see them here, visualize this kind of shareability networks. And by the way, again, I put the paper, I took screenshots of the papers. If you're interested, they're all available on our website if you want to go more in detail into the maths. But here is a visualize. What we discover, which is here in the graph on the upper left corner, is that actually with a small delay in arrival, just a few minutes, 50, 100, 150 seconds, then you can actually share 40% of the trips. You can reduce the fleet by 40% you can share 80% of the trips. You can reduce the fleets by around 40% in Manhattan. And two interesting things happened actually when this was published. First, a nice conversation started online and in different type of media. And the results ended up on the desk of Travis Kalanick, at the time the founder of Uber. And then we started the first collaboration between MIT and Uber. And as you might know, Uber Pool does exactly this, allows the people going more or less in the same direction to share a ride. Now, Uber Pool in similar systems, had a difficult time during the pandemic because of the risk of infections. But still, just before the pandemic, Uber, Lyft, Grab, Didi, and so on, all the different companies started offering similar services. And that turns this kind of ride-sharing kind of apps turn into a multi-billion-dollar market globally. So again, the little story here is you take the city, you digitize, you look at big data, then you analyze big data, you discover interesting things about the city, and those things can then be used in order to transform different dimensions of the city. In this case, mobility. Very briefly, also with similar data, with the same data actually in New York, taxi data, we also looked at other questions. In this paper, we asked a different question. The previous one was about, how many trips could be shared. And this one was, if we find a way in algorithm to do optimal dispatching, then, what is the minimum fleet we need in Manhattan in order to keep everybody on the move? So, what is we call the minimum fleet problem? What is the minimum fleet to satisfy the mobility demand of a big city? You can take cell phone data, the mobility demand of, say, Paris or New York, and then you can ask yourself, what is the minimum number of vehicles I need in order to satisfy that demand? Here is a little video. So, and here, again, if you're interested in the paper, it's here, and you find it on our website. Again, how to solve the minimum fleet. We found mathematically an optimal solution, so that allows you, again, for every city, given the mobility demand, to look at what is the minimum fleet to respond to it. And then you can ask, again, we started looking at fleets, and then we started thinking, well, that's interesting. We can also use fleets for doing other things in cities. It's not only about mobility, human mobility. It's not only about logistics, but we can also use fleets as ways to sense the city. And so what we started doing in Cambridge is put on fleets, in this case, on fleets of garbage trucks, to put a number of sensors in order to scan the city. I'll show you just a couple of images. Oh, sorry. So there's a small issue. And then, sorry about the video we kept on crashing it. But so we started using fleets in order to scan the city, and then naturally comes another interesting mathematical question, which is, well, if you want to scan a city with a certain frequency, with a certain number of times per day that you're going in every street segment and so on, how many vehicles do you need? And so we started looking at that, and we also discovered some interesting regularities. We call this the sensing power of vehicle fleets. So basically, what you see here is actually all these curves look very similar. We looked at many cities, San Fran, New York City, Chicago, Vienna, and so on. And what you see, the curve is very vertical at the beginning, which means on the x-axis, you've got the number of vehicles in the fleet, and on the y-axis, you got the sensing power, how many street segments you're scanning every day. And if you look at this, is beautiful the fact that, like in New York, the curve is so vertical that you need just a few dozens of vehicles to scan over 50% of the street segments in the city. And the nice thing is that also this looks very similar in most cities. Something I like is that the data was so nice when we plotted it, that I remember the first reviewer from PNAS thought we fabricated the data, and then we had to share all the raw data and so on. He was convinced in the end that this was the reality, but we were very surprised by this beautiful regularity we found across many cities in many countries across the planet. And then some other work we've been doing, against always, as I said, before we saw what happens if you put sensors on a vehicle and then on fleets of vehicles. But then if you add additional sensors, like the two little ears that you see there, that are LiDAR, that do a three-dimensional scan of the city, then you feed that into an AI system, and the car drives itself. And that's not the future, that's really close to the present. We're not level 5, but we are advancing quite fast. And so we started asking, what's the consequence going to be in the city? And today we have a lot of parking spaces in cities, because our cars are parked 95% of the time. But if you move to a self-driving paradigm, we can change that. And our cars don't need to be parked all the time. They can actually keep on going, and giving a lift to ourselves, to others in our family, to anybody in the neighborhood or in the city. So actually, again, we looked at this mathematically. We call this the minimum parking problem, similar to the minimum fleet. But in Singapore, we looked at data from Singapore. We got 1.4 million parking spots, but actually we could cut the number with self-driving by 70% or even 80%. This is the first paper. The second paper from last year, or a year and a half ago, looks at this in a broader mathematical sense, and you could cut it by 80% without significantly increasing total miles traveled. And then the other thing we started looking at is, if you've got a self-driving system, you don't need traffic lights anymore. You can actually just intelligently manage access to intersection like this. And don't try it yet. But again, we looked at this actually with Remita Chedekon, who was a graduate from Paris, from École Normale, and spent quite a bit of time in our lab. And then we extended queuing theory here in order to solve this kind of problem of an intersection. And what you find is interesting, again, that we can actually have a much better way to manage and use space in cities if we think about this intelligent system applied to managing access to a common shared space, the space of the intersection. That's the paper you can find online. And by the way, I'm showing you mostly work from our lab today, but our design office worked with Google in order to turn this into a real project. That's actually part of what we've been doing with Google, on using the same principle to create a street that can be programmed dynamically with self-driving cars, as you see here. I want to finish with the final project. Again, I could tell you about many others, but I'll keep it short so we have more time for discussion. And that's in Amsterdam. In Amsterdam, again, I just showed you some of the work on self-driving cars. In Amsterdam, we started working with the city, and the city has been very interested in new technologies, one of the pioneering cities in the space of urban tech. But clearly, Amsterdam is probably not the best place to test self-driving cars. It's a city where, in the historic center, you got beautiful canals, but not many roads. And so we started thinking, what about doing a self-driving boat? We called it a rowboat. They can use the rowboat for moving things around, parcels around, for moving people around, again, for sensing water quality, air quality, as we saw before, fleets of robots helping to scan the city, but also to create a dynamic infrastructure for the city. Think about pixels that float, self-driving, and then connect and create a temporary bridge or a floating stage or other things, which of course is not new. Venice has been doing for a long time. But this was at the very beginning. This was, we started 4 years ago. This is what we started with. We looked at different ways to propel the boats. You see them here, propellers like this, or water jets like this. This was the first small model, 1 to 4. You see it here. That's in the canals. Very controllable. So this was the little model. Again, you have to do that. I'll tell you a little bit more about what you had to do in terms of data. Now, basically, you had to design the whole self-driving component. This was done together with our colleagues at Computer Science, Artificial Intelligence. It was actually a big collaboration, MIT, TU Delft, Wageningen University, working with the city of Amsterdam. And on the MIT side, we coordinated the project, but really working very closely with CSAIL and with colleagues in civil engineering and also in planning. And so we had, one of the things we had to do was also map all the boats in real time today. So that's important. This is what you can see here is actually the LiDAR collecting 3-dimensional data from the canals. Is actually what helps the boat to move around, as we saw before. The LiDAR is the 3-dimensional data. And when you do that, you really see the canals from the eyes of the robot, and you can learn a lot about the city itself. So here's how, again, the eyes of the robot look at the environment. And I will not get into the details, but here you see how the boat navigates. So basically, the boat always has a number of trajectories you can follow. And then you find an obstacle, like the white element there, that's an obstacle, then the boat will change its trajectory in order to avoid the obstacle. So this is a simple, very kind of standard obstacle avoidance algorithm that applies to boats or to cars. Also, we had to do a lot of experiments. This is actually MIT swimming pool. We had to hack it for a number of weeks and test our rowboats. A rowboat is easier than a self-driving car for a number of reasons. It's slower. The complexity of the canals is lower than the complexity of a busy street. But it's also more difficult because many parameters change all the time. If the center of gravity, you can have a wave, so the response is much more difficult to predict. So we did a lot of tests in order to better understand and keep learning in real time what the response of the boat is. And also a lot of experiments to connect the boats. As I told you at the beginning, making sure they can be connected to create a temporary infrastructure. This was the first system. We've got now a much better system to connect them. This is what the students call the kissing boats. Now we have a simpler, more robust way to do it. And again, then you want to do coordinated control. That also becomes quite interesting. And here I wanted just to finish now in the remaining couple of minutes with the 1-to-1 boats. So we went to 1-to-4, then we had a 1-to-2 boat. Then we had a simplified 1-to-1. And here is kind of the existing 1-to-1. There's a few of them being tested every day in Amsterdam. You see them here moving around. And I got a small video that shows you the idea in the little tour through the canal.
This is Lucy. Lucy is a rowboat, a fully autonomous, zero-emission boat that operates on urban waterways, and she can change the way cities work. As congestion and emissions continue to rise, while cities continue to grow, the existing infrastructure of many cities struggles to keep up. Rowboats offer a solution by moving road traffic to the water. By bringing passengers from A to B, or as an on-demand boat, taking you anywhere you want. And they can also help the city as a multi-purpose workboat. Take Crystal. She is equipped to collect household waste to free the streets from heavy garbage trucks. Rowboats are fully autonomous, so they navigate without a skipper and can operate 24/7. In order to sail by themselves, rowboats need to perceive their environment and recognize objects such as bridge pillars, floating objects, and of course, other vessels. The primary source of information comes from a LiDAR sensor, but rowboats are also equipped with cameras, GPS, and a digital compass. Rowboat's onboard computer combines and processes all of the data and runs the rowboat software so it can successfully complete its mission plan. After 5 years of development, testing and experimentation, we have now successfully enabled autonomy on the full-scale prototypes. Rowboat is ready for the next step. Join us and let's unlock the potential of urban waterways together.
All right, so I'll stop here so we can have a bit of conversation all together. But thanks a lot. Thanks for listening and for having me.
Thanks so much, Carlo, for this very dense and fascinating presentation, for all these very inspiring projects. So as usual, if you have any questions that you would like to ask, feel free to raise your hand.
And by the way, I also want to add something. By the way, I see a question by Gustavo, but also if you are in Cambridge, Massachusetts, or if you are, in one of the places where in New York, one of the places where we operate, in Amsterdam with Robert, do send me an email, and it would be great to meet up and talk about some of this. But I see a lot of hands, so yeah, I don't know, Hubert, if you want to be moderating, but I think the first one was Gustavo, the first hand.
Perfect.
Yep. Thank you very much. Hi, Carlo. Thank you very much for your presentation. I have been a fan of your work for a bit now. My question goes, well, I have two questions actually. First, to what extent do you see that this kind of development, the last one's robotic developments, can be adaptable to other environments around the world, because of course you need a lot of computing power. Of course you need a lot of technicians that will be solving from coding problems to technical problems inside. So to what extent do you see that this is possible to adapt to other environments? And the second question that I also wonder about the sensors and all the data, uh, how do you see in that currently this is being applied by, I don't know, the governments, city institutions, the startups, like the sensor collecting of data to address certain problems? Do you have any examples like that they have been using this?
Yeah. First of all, the first point about how replicable things are, and I would say you don't want probably to have just universal solution. I think every city is different, and like what happened like 20 years ago with the digital revolution, that you could have these kind of giant platforms the same all over the world. I think here you really want to look at solutions that are customized city by city, and that's the beauty of cities. Every city is a bit different, and that's the result of local constraints. Is about the climate, is about topography, and so on. So I think what we need to do with with a lot of, if you want, call it smart or sensible city solutions, is really to make them very local and relevant to the local context. And that applies some of the things you mentioned. Now, computing power is getting cheaper and cheaper, more and more affordable. So that's usually not the hurdle today. But certainly, in some places, I remember something that the mayor of Athens told me few years ago, when Athens was in the middle of a big crisis, a big economic crisis, Greece and Athens in particular, it was like, well, I don't want to talk about Hyperloop. My problems are very different. At that time, during the crisis, his problems were very, very concrete, and people, needed support in very basic activities, not thinking about, crazy Hyperloop ideas or so. So I would say, yes, it's very important. We need to always start from the local conditions, and there will be different ways to tailor the solutions to the local environment. I don't think, again, as I was saying, computing power will be the key determining factor, will be one of them amongst many, but it will help, tailor the solutions locally. The second point, the second question you asked, if I understand correctly, is about how much people in cities are using data for doing different things. I don't think there's a general answer. We've seen cities being very excited about data. In Amsterdam, we've been working out with the city for many years. And Amsterdam is one of the cities that has been using data, leveraging data for very, very exciting things. In Singapore, we did a project, you find it online, called Live Singapore, based again on real-time data. It was kind of the follow-up of what I showed was, I think, 4 or 5 years after Rome, in a follow-up of what I showed you before. And it was actually more complex than what we did in Rome. Was Live Singapore, real-time feeds from many, many different sources. And that was then the basis for a big initiative by the government that was under the umbrella called Smart Nation, and that now has led to really using huge amounts of data in order to, again, to look at different dimensions of the city, from mobility to climate. So I would say some cities are really jumping on this opportunity. Other cities are behind, no doubt. So I don't think there's a general answer, but I think a lot of the mayors I talk to are aware of the fact that through data, they can really better understand what goes on in the city. And then when you know better what goes on, then you can change it, design it better. And maybe just something to finish, I remember something from Mike Bloomberg. Mike Bloomberg was mayor in New York, and we worked with the Bloomberg administration on a few things. And I remember when he was mayor, in his office, he had a sign that went, "In God we trust, everybody else bring data." And somehow, that shows that many mayors, not all of them perhaps, but many mayors really have a good understanding of how data can really change the way they understand and transform cities. Anyway, just maybe the answer was too long, but I see next hand, I see Gabor. Maybe if you could say also a couple of words about you and where you're from. It's good to get to know each other.
Yeah, thank you for introducing the inspiring projects. I'm currently in Taiwan. I'm an IoT engineer, but originally I'm from Hungary. I grew up there. And yeah, my question is something that you probably hear a lot recently. A number of experts, including some of our speakers, have mentioned that the biggest challenge in using big data projects is trust, the trust of the public or your partners. So I'm wondering, how does your group try to build trust? Because cities where there's high trust in technology probably also have more interest and therefore become more innovative.
Yeah,
so
and thanks for asking. Is first of all, I think you're totally right. I think more than trust, I think there's a lot of distrust, not because of how cities use data, but more how other companies use data, especially big tech. There's a lot of companies who know everything about our lives, and we know very little about them. So I think that's a broader issue we are facing today. Regarding cities, it's a bit easier. And for instance, a lot of the projects I showed you today, they simply use what you can call data exhaust. So basically byproducts of other operations. Some people have been calling this opportunistic data. So it's like, somebody is running a cell phone, a cell phone operator is running the network, and then as a byproduct, you get a lot of data that can help you to better understand mobility in the city, or better understand communities, or better understand, I didn't show you today, we're doing a lot of work on urban segregation, how neighborhoods are segregated and so on. So I would say that there's a big problem, the one you're mentioning, which is about trust or mistrust, but it's mostly in our pockets. It's about, the fact that our phones in our pockets collect a huge amount of data about ourselves. Just to give you the sense of the pace of this transformation, in the Rome project, when we did the Rome project, again, 15 years ago, from a cell phone at the time, we would get probably 10 or 20 data points per day. So, you would know in an anonymized way that a person with a certain identifier, don't know who the person is, a certain identifier would be lat long in timestamp, it would collect that data probably 10 or 20 times in the course of the day. And plus, the uncertainty of lat long was 300 meters. So again, we anonymized, we paid a lot of attention, but privacy was not a huge issue at the time. Again, you got 10 or 20 data points, lat long in time, in timestamp, but with a lot of uncertainty, with a lot of noise. So a few hundred meters, 300 meters, half a kilometer of uncertainty. So that was the type of data we're getting. Now today, this thing that I kept in my pocket since this morning, by the end of the day, we'll have collected probably 3,000 or 5,000 data points about me. Those data points are, many of them are based on GPS, so they have an accuracy of whatever, not 300 meters, but maybe 3 meters or even less. And it also knows plenty of other things about what I've been browsing, what I've been doing. If I was cycling, you can get that from the accelerometer. If you're cycling, if you are walking, if you are riding the car. So that gives you a sense of the huge amount of data that these things are collecting. And again, I think the problem is primarily in what happens in our pockets. We should all be aware of that. We should all, fight for a fair future related to data, who has access to it, and so on. So anyway, we can talk about that. I think GDPR, the European regulation that now is being copied, for instance, by California and many other countries, is a good starting point. But I would say the problem is, for the time being, is not necessarily in cities, is closer to us, it's in our pockets. There's a different conversation we could have about China, because in China with facial recognition, yes, there's a bigger problem in cities. But if you think about Europe and the US, is not, the key problem is not there yet, is mostly, with our smartphones. And I see the next hand by Lars.
Hey, yeah, thank you for giving that overview of your projects. So I'm Lars, originally from the Netherlands, but right now I'm in New York City, wrapping up my graduate degree in urban technology at Cornell Tech. And one thing I was wondering about.
Who are you working with at Cornell Tech? I've been there for a little bit. I had an honorary appointment there. So who are you working with at Cornell Tech?
Anthony Townsend. I'm a student, but the research I do is with Anthony, who I think you're familiar with.
I mean, what are you doing research? Okay, now Anthony is a good friend. We did some papers together, and say hi to him. Yeah.
I will. But one thing I was wondering about is if you could talk a little bit about the collaborations you have within MIT with other departments. So one thing I've been interested in is some of the work coming out of the operations research department, which also works a lot on the taxi and ride sharing optimization, right? So I was wondering, like, to what degree does your research overlap? What type of collaborations exist, and where do they differ?
Now, there's something good about MIT, which I haven't seen in many other places. In places I was teaching for a year at Harvard, for instance, which is a great university. But Harvard is organized around schools, and every school has its own endowment and different money sources and so on. Students are more separated, and so it's more difficult to do collaboration. The good thing about MIT is a bit smaller, and also the endowment is the funding and endowment is centralized, is shared across all the institute, and so it's a great place to collaborate. So for us, it's very easy. We've done, as I mentioned, the robot project in Amsterdam. We done with colleagues in CSEL, in civil engineering, also in biological engineering by looking at bacteria in water and so on. So I would say that most of our projects are very collaborative inside MIT, and then in times also outside MIT, as I mentioned before. In a few projects, papers you saw Steven Strogatz, who is a professor at Cornell, a mathematician at Cornell, and so we collaborate with him and with many others around the world. I think it's for us, collaboration is vital, is very important, is very enriching. It also helps different perspective on urban issues. So we certainly practice and apply it a lot. I'm not sure about others, and again. We collaborated with the OR people at MIT in the past, but I think different groups have different approaches. But for us, collaboration is vital. Yeah. Okay. So I see Maxime is I think he's the next.
Yeah, this is correct. Hi, Carlo. Nice to meet you again. I am Belgian, and I was a researcher at MIT when we met the first time. And I was working at MVLV as an architect recently, so we met again there when we were collaborating. So it's good to see you again and to see a new project around. My profession now is like a strategic designer, and in that realm, I have a question for you related to technocentrism and how about technology can be used to understand more a defined problem. So is it a question of definition, or is it a question of social cultural aspects? So what is your relationship to a technology? So for instance, you showing this project about sharing cabs in New York. And the question is, on a very technical approach, it might be just the most efficient way to do it, to have less cars. But then the real question is, how do people react to that? Do they want to share cars? Is car a social status symbol? So do you still want to have a car? Like, what is your relationship between technology and social cultural aspects?
Yeah, thanks. A great question. We believe that we firmly believe in the fact that technology is an exogenous force, and technology works a little bit like natural evolution by mutation. Think about, for instance, the iPhone was just a mutation in this kind of lineage. There's cell phones and then different type of cell phones, and then you had the Razor by Motorola, and then it became the iPhone, and then the iPhone opened up a new lineage of smartphones with different characteristics. So, and many people have written about the fact that some of the processes are very similar to what happens with natural evolution, which is just a mutation, and that's why I said exogenous. So we think the technology proceeds with its own mutations in a way that's a bit. That's not necessarily too related to what society needs. Think about some of the greatest inventions of the past, probably the greatest, actually, let's say the greatest invention of the past century. I think, it's probably the internet. And, that happened a bit randomly by people trying to connect a computer with another computer, not really trying to solve a problem for humanity or for society, but just, trying to, again, to generate a mutation in the way computer networks are done, and that led to all the incredible things we benefit from today, including this call. That wouldn't be possible without all of that. So so I believe in that. And then the question then when you have a research lab is what do you do? What should be your role? And we decided deliberately that we want to be almost like mutagenic effects. And I think architects, designers play that role in general, and we can play the same role in what we are doing in research. So basically, again, to try to develop new things, new conditions, and then see the feedback from society. So I don't think we deliberately decided we don't want to then say, going back to your question, do people want to abandon the car? Do people want to still keep the car as a status symbol? I think that would be a decision for them to ask. And different parts of the world might respond in different ways. I think for us, what is important is actually to show, well, what could happen in a world where people don't own a car anymore, and you share it, and you go self-driving cars and you share them, and then you show that, and then again society can respond and say, well, okay, it's interesting. We have better cities, or in other places people can say, yeah, that's interesting, but I don't want to give up my own status symbol. So again, in this kind of evolutionary process, we like to think of ourselves as kind of mutagens, and sometimes we also want to develop mutations that are not necessarily the one we believe will make better cities, but it's important to explore them anyway, to explore these kind of different conditions, because you might generate antibodies by doing that. So for instance, when we did, I didn't show you all of the Rome project with cell phone data, but when we did it at the Venice Biennale, there were different, you saw the image, you were in the pavilion, different parts, and in some parts, we also wanted to show the risks of tracking cell phone. And so, we also want to show not only the utopia, yes, everything about mobility and other things in the city, but also dystopia of, this can be very intrusive in the future. And again, it's a way to start a conversation and start feedback. So we believe that as researchers, we can focus on, again, being mutagenic agents and developing new things, new technologies, new conditions, new projects in the city. And then, that should be the beginning for a feedback loop that should involve citizens. And just to finish, that's why we spend quite a bit of time in making videos or, trying to communicate not only to the academic community, but to the broader community, because again, that's a way to start that feedback process. So that's why you want to do a nice data visualization that explains the scientific paper, because, that will be understood, if you put it online, or maybe it happened to us in the past, it can go viral, millions of people see it, and then you have a feedback loop, and again you can use that in order to decide how to move forward and to do the next steps.
Thank you.
Yeah. Thank you, Maxime. I see Anna next.
Yeah, thanks. So I'm Anna. I'm a geospatial data scientist, currently working at Bain & Company in Chile. And I have maybe a very specific question regarding CDR, so cell phone data. And this is very powerful data. Like we get a lot of information from this. We can infer a lot of movement. We can get a lot of movements in cities, insights from this, and it's important, like for, of course, for transportation planning and etc. But it's data that it's not like widely available, and maybe for local governments or big local governments maybe, but maybe for researchers it's not. So I was wondering if you've seen examples where the question is a bit asked the other way around. So if somehow we can use cell phone data from a certain point in time and use that as ground truth, and then sort of use, I'm not sure how this would work, but use like characteristics from the built environment or any sort of other data we have, like spatial data, to infer movement data from it.
Yeah, no, thanks, Francis. Well, I think we can probably do something like that, but the important thing and why cell phone data is important is that if you look at traffic, you can probably predict, if you got 1 week of traffic data in a big city, say in Paris, you can use it to predict, probably 90% of the traffic patterns in the, forever. You have 1 month or 1 week or 1 month, you analyze that, there's a lot of regularities, but the important thing is not really the 90%, which is predictable, is the 10%, which is completely unpredictable. When, there's a strike and, everything is jammed, there's a big snowstorm or there's something else. And so I think, that is what becomes very important, because that can help you to make the city more resilient, to design it better, to understand bottlenecks and so on. And then to do that, I don't think you can use the approach you're suggesting. You really want to keep on monitoring, having, say, cell phone data. Now, the good news, however, that there is many good news, and one of them is that you find quite a lot of open cell phone data that different companies have shared. For instance, Orange has been sharing since, I would say, almost 10 years ago, some of this data for research, and also, again, cell phone data is what changed a lot of urban studies in the past 15 years. Again, we were very happy to pioneer a bit that field and to work in it. But today you got also many other ways to collect data through apps, as I mentioned before, and so that is also becoming more and more available. So I would say that the availability is increasing. Is not a general trend. There's still a lot of data. For instance, the data that Google has. When you open a Google and you look for a shop or something, you see how many people are there in the course of the day. That's because Google through Android knows with a high precision the people who are going there, who are entering that place, everybody who's going in and out. It also gives in real time how many people you have in a club, in a cafe, in a restaurant, in most cities globally. Now that data is still being kept very confidential, and so yes, there's types of data that pose a problem, and we should all talk about them, because only big companies have it, and they're keeping it they're using it and keeping it very secretive. But I would say that for cell phone is becoming more and more available. Plus, you get similar kind of information today through apps. Thank you. I think we have 3 more, and I think we'll be close to. I think we only have 7 minutes. I'll be faster. But next, Tanya, where are you from, Tanya?
Yeah, hi. I'm doing a PhD in the Netherlands. I do spatial data analysis of material data, so like material stock data or waste data, to generate insights for circular cities and regions. My question is, actually, I have a background in architecture, so I did my bachelor's and master's in architecture, and I worked as an architect for a while. So my question is, what's the role or value of an architect for these urban technology projects? Because I noticed that a lot of these big smart cities are driven by technology companies like Google or Microsoft or Cisco. So from your experience, what do architects bring to the table that maybe other disciplines can't?
Yeah, I think I'll be very quick in the answer just because of time, but I think architects are what Buckminster Fuller, who was himself an architect in the 20th century and also a great inventor. He was also for a couple of years, I believe, professor at MIT. And Buckminster Fuller would have said utopia or oblivion. So if architecture keeps on doing what it's doing today, is going to, I have no doubt, is going to be oblivion. It's totally irrelevant. Only 2% of buildings on the planet are designed by architects. Usually is about beautifying, stuff that would be built anyway. But actually, I believe that if architecture looks at the key challenges of our time, and I think we looked at some of them, we were discussing some of them today about cities, about carbon emissions, about climate change, about urban segregation, social segregation in cities, and so on. Then, then it can be, as Buckminster Fuller said, it can be utopia. So I think, first of all, we need to change what the perimeter of architecture is. I would say architecture and design. We need to look at something we started calling like design at large, involving many disciplines in order to tackle this kind of big, complex, interdisciplinary problems. And we need to, that goes together with the training and what the role of universities. And I think in the case, going back to your question, the role of the architect can really be the person harmonizing many voices. So the architect can really help bring together, the designer at large, bring together all the different disciplines, as you saw before, going from complex science to sociology to economics to mathematics, in order to tackle and solve those problems. Anyway, thanks for the question. Nikhil.
Hi, Carlo. How are you?
Great.
Good to hear. I actually work at Lincoln Labs. at MIT, and so anyway, it's nice to see your work.
You are a Lincoln Labs. Okay, then you should stop by our lab. You're not that far.
Yeah, it's pretty close. Anyway, cool talk. I had a couple questions. Maybe I'll throw them both at you, and you can pick one that you're interested in for the sake of time. I'm kind of interested in human-machine teaming, and I'm curious how you see the growing collaboration between what sensors and sort of the smart city enable, and sort of what computers can enable, and what are the roles of human going forward, and how they sort of partner in meaningful ways. And then the other question I had was about sort of long-run planning, which is sensors kind of capture a partial truth. They capture what you think you know in a lot of ways. And I'm curious, how do you say, what is the impact of what's not measured, and how do you make sure that what you're measuring through the sensor is actually, reflective of the actual truth of what's in a city, and how does one account for that, and especially in a long-run planning sense?
Yeah, that's great. I'll be very quick just because of time. The first point is we could talk for a long time about singularity and your role of machine, the future of machines and the future of humans. But I will only say something. I think one of the biggest challenges we have today is really the alliance you're referring to. And it's not only the alliance between humans and machine, but more generally is the alliance between the natural and the artificial. So the world of the natural and the artificial, actually the fracture between the natural and the artificial is what brought us to the crisis today, in particular the climate crisis. So I believe that the key challenge we need to face, and that again goes back to what could be the utopian role architects can have today, is really to help create a new alliance between the natural world and the artificial world. And again, there's a beautiful book by Herb Simon, again, great researcher, mathematician, got the Nobel Prize in the past century. The book is called The Sciences of the Artificial. And I start from one can start from his definition of the artificial and see how really, however, we can create a new alliance with the natural world. That would be my general question. Regarding the second question about the importance of what can be measured, I think it's a beautiful philosophical question. Again, I don't know how I can try to give an answer in like 20 seconds before the next question. But I'll give an answer by analogy. It reminds me a beautiful short story by Italo Calvino. Many architects know Italo Calvino. He wrote this book called Invisible Cities, which is kind of almost like a textbook in many architecture schools. And in one of Calvino's short stories, there's this thing about a piece of music. Mr. Palomar is listening to birds and then to the sound and to the music, and then starts looking at one point, not at what you can measure, which is the notes, the pitch, and the length, but actually the silence in between. And then he starts looking at the world just by contrast, by what is not there instead of what is there, what is empty instead of what is there. So that's what it reminded me. I think it's a beautiful question. We could discuss it. We need more time to discuss it indeed.
Sure.
And if you stop by the lab, if you're at Lincoln Lab, stop by one day and we'll continue.
Sounds great. Thank you.
I see. Look, yes.
Yeah, the last question, I think. I'm Lucas from Berlin. I used to work a lot with space syntax at UCL before, looking at urban movement and segregation. And now I work as an architect for large-scale projects and urban projects in the Middle East. And I was wondering, actually, you said, and I know that you're also working a lot in design, let's say, in actual physical design. And I always found it hard to kind of bring the knowledge and the learnings from kind of very abstract theoretical research or even very detailed technical research into the design process, which is at many times also quite random or subjective. So I was wondering how you bridge this from your work at MIT into your work in your company.
Yeah, no, thanks. Thanks for asking this, but I don't see the fracture. Maybe it's a good way to probably to finish. Yeah, we're just in time. But basically, again, if you go back to Herbert Simon, we mentioned before, Herbert Simon has a beautiful line in that book, The Science of the Artificial, where he says basically the natural science, quote, the natural sciences look at how the world is, And design looks at how the world ought to be, or how the world could be. And to me, it's a very beautiful definition, and that combines, again, in the research we're doing, like think about when I showed you the shareability networks paper, the PNAS paper about sharing mobility. That for me is a design paper, because it looks, again, is asking a question: what's a different way you could run mobility in a city by allowing people to share a ride? And many of the other things I showed you are designed by this definition. In the same way as what we do in our design office, innovation design office is designed by the same measure. So it's about not looking at how things are, but looking at how things could be, how things could be different. It goes back to what I started with at the beginning about, trying to look at the future not as something to predict. There's, it's impossible to predict, as Popper said, but the future is something we can build together, again, by using the tools of design, and that can apply equally well to the research in a lab, and to what you do in a design office, or what you can do in a startup. And maybe that's a good way to end. But thanks a lot for all the questions. Again, to be continued. If you are near some of the places where we are based, do come and say hi, and we continue the conversation. And if not, let's keep in touch.
Thanks a lot, Carlos, for the presentation, for taking the time to answer all the questions, and also for this beautiful conclusion. For those of you who want to stay in the room to discuss the lecture, you are more than welcome. Thanks, Carlo.
Have a wonderful day.
Bye. It's King's Day today in the Netherlands, so I'm gonna go have fun.
Yeah, exactly.
Okay,
bye, everyone.
Enjoy.
See you.
Bye. So hope you enjoyed the lecture, Nikhil, Lucas.
Yeah, it was super interesting. Yeah, what do you think, Hubert?
No, that's really great. I really love Carlo works and projects. Also, it's very interesting because it echoes. So we had a collective intelligence session last Friday, and it was about localized technologies. So how you can make it more local, and it's super inspiring because in each of his projects, Carlo is doing this. Like taking into consideration the local context in Amsterdam, in New York. So that's also super inspiring.
Yeah, I love how much time they spend on making very beautiful visualizations. It makes it very accessible, and they're always very pretty.
I think you have to do it if you want to reach a certain audience in architects and urban planners. If you don't do it like a really nice visual, then people are just going to dismiss it and not even look at it. And they're doing a really good job at MIT, I think, always. You have to go visit them. Huh?
Yeah,
they're right next to you.
But Nikhil, are you based in California or in Boston? I thought you were in California. No?
Yes.
Where? Sorry.
Yeah, I'm in California. I bounce between them.
Okay.
I'm in San Francisco.
Okay. Yes.
But I bounce between the bridge. I have a very fiscally irresponsible strategy where I have an apartment in Boston and an apartment in San Francisco.
Nice.
Expensive strategy.
Nice. No, I think it was a great lecture. Actually, I was very happy because the last time with Sandy Pentland, he kept it like very on the surface. I felt in some ways. And I was really looking forward to that one. And at the end, I was a bit like, come on, you don't have to sell us something. We want to know the details. And Carlo Ratti, he really went into it and he really showed all the details. That was really cool, I think.
That's why it's really two very complementary lectures. Like Sandy Pentland, it's very conceptual with the idea of social physics. And with Carlo, you have more like real projects. What can you do with this idea of analyzing urban data, etc.? That's great. And next week we will have another lecture, so it will be about meaningful inefficiencies, and you will see it's quite interesting because it goes against what we saw with Carlo and Sandy. The idea to add inefficiencies in the loop, not always optimization.
Nice, that's great. Yeah, that's going to be a nice one. I'm also looking forward to that one a lot.
Do you enjoy the program so far? Like, would you have recommendations of improvements or?
I think it's really cool to hear all these guys. Sometimes it's hard for me to attend all the different things now, also organizing with the breakout groups and so on.
Okay.
But I think it's really cool to see and be able to interact with these guys. And yeah, I think for the paper, I don't know what you think, Nihil, but at least for me, I think maybe 2 weeks is maybe a bit short. I guess it would be helpful if we can just submit it towards the end or before the team phase, I guess.
Yeah, so it will be extended actually. So maybe it will be more like 3 weeks and 1 month. Not more, because the idea then is to have the feedback of the lecturer. So for example, I don't remember which lecture is your paper, Lucas?
Sandy Pentland.
Okay, so for example, you will have feedback from Sandy, and also because we want to publish them, and like this to have feedback, etc., to potentially integrate them in the final book.
Nice.
Nikhil, what?
Yeah, I really enjoy the program. Thanks for organizing everything. It's super cool to talk to somebody or hear so many different people talk. And I think, yeah, the only sort of gaps that I see are the sort of getting to know the peers. But I think this collective thing is a good way to do it. But the other thing is, and I have this attitude in life in general, which is whenever I see something cool, I want to go do it. And so, all these different professors and people, I want to go reach out to them and collaborate with them in some way.
Yeah.
And so I think if there was a way to facilitate that kind of interaction, like I was going to send you some messages to ask for this guy's email and Pentland's email and some other people, just to say like, hey, do you want to work together on something? And it makes sense for them because often they're very idea rich, but they lack the time and the energy to go pursue it. And I'm in the opposite place, in my life. My labor is super cheap. And so, it would be cool to sort of partner. And if there's shared interests, it can potentially be a meaningful partnership. I'm not really sure in terms of what that means in a solution, but I'm giving you a problem. So.
Well, let me know which emails you would like to have, or if you need introduction, and obviously I will do it with pleasure. And continuing what you say, with peer connections, this is what we are trying to do. Not so easy, when it's like kind of remote program. If you have really any idea, feel free to share, I don't know, like informal event or something that you did and that works quite well for such connections. Let me know, and yeah.
Yeah, for sure. Yeah, I think I'm not really sure of the forum. Once again, like for instance, I like writing academic papers all the time. I've started a few things company-wide. I'm always interested in starting another one. And it would be interesting, especially if there's shared interest. Like it seems like it's a pretty entrepreneurial and also pretty research-oriented group. It seems like a natural fit to be like, hey, we should go start something together,
Maybe it's like something that comes after the team phase where we actually keep going with kind of connecting everyone closer together rather than just bookending it. Maybe it's something that can, evolve out of that we don't try to fit that extra stuff also in to that period, but try to extend it so you can actually interact, over time a bit more.
Yeah, that makes sense.
What we are trying to do is like every 2 weeks, those kind of collective intelligence session. The goal is really to let you better know each other. This is really the goal, This is why I'm creating each time group with people that you don't know, like people that will be different from your papers and from your future team project. So this is the goal of this collective intelligence phase. And did you connect with what did Jasmine? Like she created a kind of bot to exchange together. Does it work?
I haven't tried it yet personally.
The Miro board?
No, she. I don't know if you remember. Like she created a kind of. I don't know if you see what I mean. Like a bot, like on Slack, and it.
You mean the shuffle? Yeah, the shuffle thing.
Yeah.
No, that's nice. Yeah, actually, I'll do that today with Maxime and someone else. Gustavo.
Okay, so that's amazing. Okay, cool.
But it's always hard to find a spot because then it's like everyone works like their usual 8 hours, and then you have to do before, after, and the lunch break and everything.
Yeah.
But I mean, it's a really cool program, and everyone is, I think, very interesting peers also.
Well, great. Okay, guys. Well, see you next week for the lecture with Eric Gordon, and have a beautiful day.
And sorry, this Friday, is there another of this collective intelligence?
So,
no.
Okay, so yes, that's a good question. Usually the other collective intelligence session should be not this Friday, but the other one. But actually, we have an issue with Eric lectures, who will be next Friday. So we will see how we can schedule this, but it will be very soon. Yeah. And maybe this time it will be a debate, or maybe a debate about the 15-minute city, because we'll see.
We had this interesting format once at UCL where we were given like teams of 3 or 4.
Okay.
And we were given like a one article or one book or one chapter of a book maybe. And then you're kind of debating with another team of 3. So you have like a paper and the other team has a paper, and you're given like, I don't know, 2 minutes opening, the other one 2 minutes opening, and then 3 minutes head to head. And then it's like some evaluation afterwards. So it's like 10 minutes, and you kind of are in this kind of exchange. I also thought that was quite we had like Karl Popper, I think, as a Karl Popper versus this other guy from
Okay, so you have 2 different papers that have 2 different ideas, and each team has to defend. Okay.
I mean, they don't have to necessarily be antagonistic papers, but they can just be like papers on the same topic or a similar topic that maybe have a different approach or something. So I always thought I thought that was quite a successful one, because then you get to engage.
Yeah.
You don't write it down and you send it somewhere, but you have like the other 3 guys there, and you're like, okay, but what about this? And that's kind of a nice,
That's a very good idea. I think we'll do this for the next collective intelligence session. That's a great idea. Yeah. And like this, you also learn like new concepts. Like that's great. Thanks for the tips, Lucas.
Yeah, no worries. Cool. Then.
All right. I have to pop off, but it was nice seeing you guys. Have a great weekend.
Yeah. Bye, guys.
Bye-bye.